at question 13 of the AQA June 2022 paper. So it says here, the figure shows the approximate shape of a vertical cross section to the entrance of the cave. The cave's horizontal floor and the cave joins the floor O and P. Gary models a cross section of the cave using that equation. So that curve there is modelled by that equation, where A is constant, X and Y are the vertical and horizontal distances in meters from point O. OP is 16 meters. Find the value of A. So this is just thinking about what do we already know and what values we can put into our equation. So let's think about X and Y are the horizontal and vertical distances measured from O. So let's first of all think, when Y is 0, let's try that again. When Y is 0, that means that I'm at the floor. So we are at 0 at O and P, aren't we? And O, if we think about what the vertical distance from the horizontal distance is here from point O, it would be O. So that coordinate is OO. And then here we know its Y coordinate is, I should say 0, is 0. What about its X coordinate? Well, we know the distance from OP is 16. And we know that X is the horizontal distance from O. So that must be at 16, 0. So we should be able to substitute in those values to find what A is going to be. So let's do that. So we end up with X squared, and then I'll just do the plus 0 there. So it's just X squared equal to A root X minus Y, which is also just going to be 0. So then let's get all of our X's on to one side here. So I'm going to do X squared over root X is equal to A. So if I do that, that is X squared divided by X to the power of a half, which is actually just going to become X to the power of 3 over 2. If you think about it, we're doing 2 minus a half. So that's 1.5. So X to the power of 3 over 2 is A. Or either, if X is 0, then A is 0. That doesn't really mean much to anything. So I think we'll be using 16, won't we? So let's think about if we put 16 in there. So we have 16 to the power of 3 over 2 is A. So I would square root the 2 to get 4 and then cube that. So that gives me 64. So I'm going to say that A is 64 there. So that wasn't too bad. That was just about thinking about what our equation, what do the values of X and Y actually represent there. So part 2 of the question says, show the maximum height of the cave above OP is approximately 10.5 meters. So I think we are going to have to, maximum, we're going to have to differentiate. We're going to have to use implicit differentiation here because we've got X's and Y's in it. So let's do that. So we're going to do 2X here. And then we're going to differentiate Y with respect to X using chain rule here. So we're going to get 2Y dy by dx here. And then that will give us 64x to the power of a half. So again, let's differentiate that. So that'll give us 32x to the power of minus a half. And then minus y, differentiate that. We're going to get minus dy by dx there. So we end up with that. Then we need to get all our dy by dx's on one side of my equation. So let's do that. So I'm going to end up with dy by dx, and then I have 2y, and then when I add that dy by dx over, that gives me 1. And then end up with 32x to the power of minus a half minus my 2x there. Like so, and then we can divide by that 2y plus 1 there. So we end up with dy by dx is equal to 32x to the power of minus a half minus 2x over 2y plus 1. So we end up with that. And then we need to set that equal to 0, don't we? We need to set that equal to 0. So that means for that to equal 0, the top bit has to equal 0. The bottom, if we try and mess with that, it's obviously, if that's 0, it's undefined. So we're just going to make the top equal 0 because the numerator equals 0, the whole thing's going to equal 0. So let's do 32 x to the power of minus a half minus 2x is equal to 0. And then add the 2x across, we're going to get 32. I'll just put x to the half down here is equal to 2x. We end up with that. And then let's multiply that x over. So we get 32 is equal to 2. Don't know why I've written a 3 there. 2x to the power of 3 over 2. And then let's divide by that 2. Divide by that 2, so that gives us 16 is equal to x to the power of 3 over 2. Now, that's not going to give me a very nice number. It looks like it should work, but it doesn't give me a nice number. So I'm just going to say that x is 16 to the power of 2/3. I've just inverted the powers there. So I've got that. But now I need to think about what I've actually been asked here. I've not been asked for x, I've been asked for y. I need to show the maximum height is that. So I can now just put that back into my original equation with x's and y's in it, and that should give me what y is. So when I substitute that in, so all I've done there is I've just substituted that into, that equation. So x squared plus y squared is equal to 64 x to the power of half minus y. So I've just substituted that into there, and I get this lovely thing down here. So we can then just rearrange that into an equation for y, and it's actually going to give us a quadratic. So it's going to give us y squared plus y. And then if we take away the 16 2/3 squared, so it'd be 16 to the power of 4 over 3, that will give us, adding it to the 64 times by 16 to the power of a third, that'll give us minus 120.95. And I can leave it as a not exact value here because I know it said what the answer is approximately 10.5. So you then just solve that quadratic equation to end up with y equals either 10.51 or y equals minus 11.51. So obviously the distance can't be negative, so it can't be that one. Vertical distance can't be negative, so therefore we've shown there that y is approximately 10.5 meters. So y is 10.51, which rounds to 10.5 meters. 10.5 meters. So just something on those lines just to say that, yes, that is what you get. So then it says, suggest one limitation. And this is only 1 mark, and it's basically just common sense. So if we have a look at the diagram, and sometimes you think like, oh, this is actually quite difficult, I don't know. But you think, like, what cave have you seen that looks like that? Is it going to be perfectly smooth? Is there going to be no sort of like indents or little crevices or anything like that? It's not going to be perfectly smooth, is it? So that is what I would say there. I would say it's unlikely that the cave is perfectly smooth. So it is unlikely the cross-section of the cave is perfectly smooth. Cave is perfectly smooth. And that is that question. So it was a bit of implicit differentiation, but other than that, it was just a bit of rearranging, really.